And we're going to do like a little practice test today. Couple of reasons. It'll give you an idea of what you're going to see on your test, and we're going to practice doing it like within the time limit and uploading, and make sure that if we have any issues, we figure them out together, whether it's I have an issue in terms of grading it or you have an issue in terms of submitting it, that we figure it out before it's the test. So that's our goal today. And then you guys will start the review. So your assignment was the second half of 2-6. So it's like 20, 21, 2. Okay, so started at the end of the assignment. So on question 20. Sure. Okay. So these questions, I think the hardest part is really what you remember about trig. Okay, so for your test, make sure you have this stuff memorized. Okay, so it really isn't too bad unless, yeah, it all really comes down to if you have all your trig stuff. So there was a question on 17. So on 17, we have to find f prime. Writing the equation of a tangent line, you need slope. So Milo, what is the derivative of negative cotangent?
Secant.
Nope, not quite. So cotangent, we cut them up here. It starts with a C, so the sign always changes, so negative cosecant squared. Good. Okay, so this is, it was negative, so it changes to positive. So that's the derivative. That part right there is either you have it memorized or you don't, right? So that's just a straight memorization. So you got that memorized. Then we evaluate at pi 6. If we plug in pi 6, the first thing that bothers me is how the squared is written. I always like to think of it as the quantity squared. And cosecant. Cosecant is defined as 1 over sine. So I'm going to write that as 1 over sine of the pi 6. And then the squared is that whole thing squared. So I always put the squared, like ignore that, do the inside first. So again, from memory, what is sine at pi 6? 1/2. So this becomes 1 divided by 1/2. But what's 1 divided by 1/2? 2. So really the inside is 2, and then we square it and we get 4. What is this? What did we find? Slope. What else do you need? Point. Fortunately, oh, they gave us a point. I didn't notice this. Somebody else noticed it. That y coordinate's wrong. But I'm not going to like waste time on it. But if you actually took time to plug in pi 6, you would have gotten out, I believe, 1 over root 3. So it should have been 3 over root 3 or 1 over root 3 or something. But it doesn't matter. We're just going to go with it. Okay, so I'm going to use that point, this slope, because they gave it to us. So we're just going to, or they gave us the point. So the tangent line, we just leave the slope in front. X minus the x coordinate, and then plus the y coordinate. The y coordinate's negative, so I just leave it negative. Do not simplify at all unless you had to, and the only time you'd have to is on a multiple choice, and it'd be pretty obvious what steps would be necessary. Okay, and then 20, I can already see why 20 is going to be kind of bad. What makes 20 a little bit messy? Product rule. Yeah, I don't think of tangent is necessarily that much worse of a derivative, but I see two functions because I have x in both pieces. So I see the times sign right there. So I see this is 3x times tangent of x. Joe, tell us the derivative. What is g prime going to be? Are you able to find the derivative of this?
G prime on that one.
We're going to do product rule, right?
Product rule, yeah. So tangent is secant squared.
Okay, so hold on 1 second. Tell me product rule. What is product rule?
Oh, it's the first times the second, and then the second.
Okay, so now do it.
3x.
Good.
Times secant squared of x.
Very good.
Times tangent x times 3.
So plus tangent x.
Plus tangent x.
Good. And the derivative of the first? 3. I'm just going to go ahead and write that 3 in front of the tangent because I usually write it there anyway. Everybody okay to hear? These, they really are just messy because now we're plugging in pi 4s. we're just going to simplify as much as we can. So we're going to have 3 times pi fourths. And then secant, I'm going to write it as pi fourths. I want to write that as the quantity squared. And then 3 times tangent of pi fourths. How many of you feel like you've got your trig stuff memorized? Like you look at this and you're like, I know how to do it. Very few. So just a reminder on your module, let's see if I can show you. I would recommend practicing. I believe I have it on your home page. Does it take me to your home page? Student view? Yes, okay. So on the home page, if you scroll, there's that link to the trig flashcards. So if you need practice, go to this page and practice here. You could do values of sine, cosine, tangent. In all 4 quadrants, always practice radians. So you could practice these. So you can just quiz yourself, sign at this, try to answer, and then check. Okay, so if you are struggling, I promise you this is going to be an issue all year long. You're going to miss a lot of questions where you might know other stuff but not know this. So practice this. If you're struggling, tell yourself to practice like 10 minutes each night. Just practice those. It really won't take you too long if you just commit to practicing. So when I see secant, I want to rewrite it. How should I rewrite secant?
We can't see anything.
Ah, thanks. Were you ever able to, or did I never share? Maybe I totally forgot.
We can see a screen, but I just realized that you've been doing problems and we're just looking.
Thanks. Oh, it says I'm presenting. What did I do wrong? Let's just try again. All right, whoops. Can you see my screen now? Has problem 20 on it?
Yeah.
Okay, thanks for telling me. Okay, so I want to rewrite secant. What is secant? How can I rewrite secant? 1 over cosine. I'm going to make a little list really quick. This is what you need to have memorized, right? So this is kind of how and it would be perfectly acceptable on a test that if you have these memorized, once you get your test, you write this out on your paper. So you can just memorize it and then write it out. So the first one, pi 6, I go 30 degrees, 45 degrees, and then 60 degrees. So I always list them smallest to biggest. Okay, so if you have these 9 values memorized, it really isn't too bad. Sine at pi 6 is a half. For me, I basically memorize this one, and then the first 2 rows fall into place. If that's a half, pi thirds is the ugly one, the root 3 over 2. Cosine, those 2 angles just flip. Those 2 values flip for the angles. So this one is the root 3 over 2, and this one is the 1/2. So if I can remember that first one, sine at pi 6, is a half, then I've got all 4 of them. Okay, pi fourths is a 45-degree angle. So sine and cosine are the same because the opposite side and the adjacent side are the same. So this is, I memorize it as 1 over root 2, but you also can memorize it as root 2 over 2. But those 2 are the same. If we proved it, that works because a 45, 45, 90, you have 2 congruent sides. If I did Pythagorean theorem, that's like where that 2 comes from. So that's kind of how I remember there's that square root of 2 from 2 congruent sides. Okay, tangent. Well, tangent at pi fourths is 1 because tangent is defined as sine divided by cosine. Those 2 things are the same thing, so it should make sense that one's 1. Tangent at the smaller angle is 1 over root 3. Tangent at the bigger angle is root 3. So if you're struggling with these, it might be a good idea to just practice writing this box, and then when you start a test, as soon as you start your test, you can write on the top of your paper in the corner, you can write this out. So it would be totally acceptable to do that. Yeah.
You know how on the flashcards it was like
Pi thirds?
Yeah.
Good. So good question. So if it's not one of these from quadrant 1, so let's do the one that was on the flashcard. So the one that came up with sine of 5 pi thirds. The only difference is if the numerator isn't a 1, you have to decide on the quadrant. So then I go, okay, halfway around is pi, but I'm going to rewrite pi with the denominator of 3, so I'm going to consider that 3 pi over 3. All the way around would be 2 pi, but whatever the denominator is, I want to rewrite it with that denominator, so 2 pi is equivalent to 6 pi over 3. Because comparing this to those angles is what's going to help us decide on the quadrant. So what quadrant does 5 pi over 3 fall in? Fourth. So I know my answer is in the fourth quadrant. The only reason we care about the quadrant is because it'll tell us if our answer is positive or negative. Does sign go with X or Y? Y. So sign goes with Y. And what I mean by that is it's going to be positive and negative where Y is positive or negative. So in quadrant 4, are the Y values positive or negative? Negative. So the only reason I had to decide on the quadrant was to know the sign. And then I just look at the table above. I'm looking for a pi thirds angle, and sine at pi thirds is the root 3 over 2. So that's how I know the answer is root 3 over 2. Does that make sense? Okay, so just for practice, I want to show you guys one more because it does seem like I only saw 2 hands to people who feel like they're comfortable. Let me make one up. Let's say I asked you for tangent at 7 pi 6. Okay, so the first thing we're going to ask is what quadrant we're in. Eric, what do you think? What quadrant might we be in? Third quadrant. Very good, because halfway around is pi, so that'd be 6 over 6. So Grant, 7 pi over 6 falls right here. Okay, Grant, in that quadrant, do you know if tangent is going to be positive or negative? What was that? Negative, but how did you know that? Very good. Tangent is defined as sine over cosine. Sine is y, cosine is x. So it had negative y values. Oh, sorry, so it shouldn't be negative, it should be what? Should be positive, because y is negative and x is negative. So a negative over a negative is positive, so it's positive in that quadrant. All right, so there. Okay, and then Will, what is tangent at pi 6?
1 over root 3.
Good. So then you just look at the table, you get 1 over root 3. Okay, so if you just practice writing this out, like writing that, if you were to write that even 10 times, I don't know if you guys remember like back in elementary school when you had to study for spelling tests. How many of you remember like you just write the word like 5 times, right? And then you write it 5 times, then you know you've got it. If you just copied that on your paper tonight and wrote it down 5 times after, I bet you have it memorized. So really take the time to do it. It's going to come up all year long, and you're just going to continue to miss things. So cosine at pi fourths. From that table, what is cosine at pi fourths? 1 over root 2. So I make that substitution. So this is 1 divided by 1 over root 2. But what happens when we divide by a fraction? This flips it, right? So 1 divided by that just becomes root 2. But it's still squared. What's root 2 squared? 2. So that works out pretty nice. So that piece, we still have the 3 pi fourths in front. And then we have times 2. Then we have 3. We still need to figure out what tangent at pi fourths is. Well, from the table, what's tangent at pi fourths? 1. So it's just 3 times 1. We can't really go much further. I could reduce the 2 and say that that's 3 pi halves plus 3. What have we found? Well, this is a bad one. What have we found? The slope. It looks bad, but we're going to treat it the same way as anything else. On 20, did they ask us? Sorry. They asked for the whole tangent line, right? Yeah, we need the tangent line. What else do we need besides the slope? The y coordinate. So we go back to our original function. So to find the y, you have to take this x and plug it in here. So the point is found by evaluating g at pi fourths. So the original function was 3 times x times tangent of that x value. What is tangent at pi fourths? 1. Fortunately, that's 1. That's pretty easy. So g at pi fourths is just equal to 3 pi fourths. Still pretty ugly. So the point is pi fourths, comma 3 pi fourths. If you can accept the fact that our answer is just going to be ugly, it really isn't any more difficult. It just looks terrible. This is our slope, so keep those 2 terms together. This is our point. So our tangent line will be y equals, we write the slope. I would keep it in parentheses because the whole thing is would have to multiply through if we needed to. But there's the slope, and then x minus the x coordinate, and plus the y coordinate. And that's it.
Maybe
Did I mess
3
up?
pi halves.
Say that again.
Maybe 3 pi halves.
It should be. Thank you for catching that. This one over here, that needs to be a 2 on the bottom. Okay, so let's say this was on your test. You left it like this, you'd get full points. I'm going to make one change. What if I was grading one that didn't have those parentheses? Do you think I could give them full points?
No.
That's no longer equivalent without those parentheses. Why is that no longer equivalent? What's understood to be needing to be multiplied through those parentheses of x minus pi fourths?
So,
It should be the slope, but without the parentheses, only the thing directly in front, so only the 3 would be showing that it needs to multiply through. So if your slope is something ugly, just throw parentheses around it. If it's a single number, it's not necessary. But if there's multiple pieces, you really do need to keep that there. So yeah, that one was pretty bad. Okay, then I believe it was 21. 21 calculator one. We did this together in class yesterday, right? Yeah, we did that one. Okay, 22. This is a good one just in terms of practicing our trig and arithmetic. It actually doesn't even use calculus, like we're not taking any derivatives. But rules of fractions, like elementary math, is probably the hardest part here, is the stuff that you learned in elementary school. It just looks terrible because there is like a pi in it, but the rules are the same. Average rate of change, the formula for AROC, you need to remember that AROC is always F at B minus F at A all over B minus A. Even though it's going to look terrible, we do the same. We are taking our normal process. Here's A and here's B. So first I need to find F at B. F at B is just saying take pi halves, plug it in for X. I'm going to write it out, but it's going to look terribly ugly. So I'm going to have F at B is pi halves divided by sine at pi halves. I'll come back and reduce in a minute. But F at B was this. We are at that. Just replacing X with the B value. So then F at A would be pi 6 because pi 6 is A divided by sine at pi 6. So again, this piece is just the F at A. It was just taking the A value and plugging it into that function. Try not to let like how messy it is stress you out yet. So far I've got F of B minus F of A. What am I supposed to divide by? What does the formula tell us? B minus A. So what do I plug in for B? Good. And then it's that minus A, and A is pi 6. Yes, Hallie.
You can do it like switch the pi 6.
You could, yeah, good question. Yep. So if you wanted to, so this is equivalent. If you had done F at A minus F at B, that would be totally fine. You would just have to switch the denominator. So yeah, great question. Okay, now one thing, if this was a free response, if this was on a free response test, guess what? You could stop right here. So practice writing your stuff out nice and neat, because as long as it was nice and neat on a free response, you don't even have to evaluate the trig. This won't be a free response question on your test, though. This would be one where I want to see if you can simplify it. So you're forced to simplify it. Okay, let's start by evaluating these pieces. What is sine at pi halves? 1. For me, I think of the graph. I kind of visualize the graph. Sine at pi halves is 1. So when I rewrite this, I've got pi halves divided by 1. I'll deal with that later. Over here, I have pi 6 divided by sine at pi 6. From the table we just wrote, what is sine at pi 6? 1/2. This is divided by 1/2. What happens when we divide by a fraction? Good. So again, I think the hardest part about this is all the elementary stuff. So like dividing by a fraction, you flip and multiply. So that's pi 6 times 2/1. That could reduce to, let's see, 2 can go into here 3 times, so that reduces to pi thirds. Dividing by 1 wasn't a problem, so the first piece was pi halves. The second one is now pi thirds. I'm going to take off that because I didn't really write everything out. But right now, I'm to here. I still have pi halves minus pi 6 in the denominator. Can I cancel out those pi halves? Can I do this? No. If you look on my board, when you leave that orange one, it's one of my favorites. It says every time you do this, a kitten dies. I see this so often. So it's showing something like this. Anytime you cancel something out like that, where it's put together with a plus or minus, kitten dies. I don't even like cats, but don't do that. Okay, so you cannot cancel it out unless it's a product. How else could we work with this? Think of it again, just like back in elementary school. What do we need in order to add two fractions together? A common denominator. So ignore the bottom piece. Let's just think about this top right now. I want these two denominators to match. What could I make them both become? We call it the least common denominator. Sorry, my brain forgot the word. Least common denominator. What was it I heard? 6. So if we want them both to become a 6, this first one we'd have to times by 3. So that would be a 3 pi over 6 for the first fraction. The 3 we'd have to times by 2. Whatever you do the top, you have to do the bottom. So then that's minus 2 pi over 6. What's 3 pi over 6 minus 2 pi over 6? Pi over 6, because it's 3 minus 2 is 1, so it's 1 pi over 6. There's the numerator. We're going to do the same thing with the bottom. What's the common denominator between 2 and 6? 6. And that's great, because that means the 2 is the only one I have to multiply by. So I want to multiply the 2 by 3. That way I get a 6. So that would be 3 pi over 6. We don't have to change the pi 6. It already had the right denominator. What is 3 pi 6 minus pi 6? 2 pi 6. So it looks ugly. We were able to get the top to become pi 6. We were able to get the bottom to become 2 pi 6. What do we do when we have a fraction divided by a fraction? Flip and multiply. So this becomes pi 6 times 6 over 2 pi. The 6's cancel, the pi's cancel, and we get. So all of that mess of stuff was really a review of fractions. Okay. They will intentionally write multiple choice questions where you have to do this stuff since they know that they're not going to be testing it in the free response. You really have to be comfortable simplifying your answers. So practice it on your homework. Okay. I think that was there. Oh, 23 and 24. Okay. 23, they just said rate of change. So on 22, they said average rate of change. What are they talking about on 23? Instantaneous. How do you find instantaneous rate of change? Derivative. So I'm not going to go through it. Well, yeah, I guess we have a second to do this really quick. Okay, so same question, same function, but it's instantaneous rate of change. So we need the derivative. So let's see, Berkeley. What rule do you think we have to apply to take the derivative of that function? Quotient. Very good. Do you have quotient rule memorized?
Yeah.
What is it?
It's
Good. Good. I write it in that order, but you're right. That's the same thing. And then it's all over what? Great. Okay, so if I follow this, we've got the bottom times the derivative of the top, which is 1 minus the top, times the derivative of the bottom. What's the derivative of sine? Cosine. And it's all divided by the bottom. I always write it in parentheses, squared. And then we just have to evaluate it at pi 6. So I'd have sine at pi 6 minus pi 6 times cosine at pi 6. Yuck, ugly. Sine at pi 6. I do think it's worth practicing because of the arithmetic stuff. Okay, Sean, you have memorized what is sine at pi 6? It is, very good. So that first term is a half. Then the pi 6 over here I can't do anything with. Haley, what is cosine at pi 6? Great. And then on the bottom, sine at pi 6, as Sean said, that was a half. So this is 1/2 squared. What's a half squared? A fourth. So we're dividing by a fourth. So again, I just want to make sure we're comfortable simplifying. So on top, I would write this as, well, in fact, what do I want the top to have? Possibly like I did on the last one. I want to be able to combine these together. I'd want a common denominator. You guys okay with that? Agree? So I kind of like that these aren't multiplied together. This one has the 2 but not the 6. So my thought is let me just multiply top and bottom by 6. So I could rewrite that as 6 over 12 minus pi root 3 over 12. Or together I could say it's 6 minus pi root 3 over 12. We're dividing by a 4, which is equivalent to doing what? Timesing by 4. So I'm really multiplying this by 4 over 1. The 4 can reduce with the 12 and we get a 3. So I'd have 6 minus pi root 3 over 3. The hardest part of this class is the arithmetic, I think. It's usually where we see more mistakes. Okay, I'm just going to mention the last one and then I want to go on. So this one, they want x coordinates of a horizontal tangent line. You have a question similar to this on your free response. When it says horizontal tangent line, if it's on a free response, you get a point for making some statement. What's true at any horizontal tangent line? Slope is 0. Okay, so horizontal tangent line slope is 0. How could we write that in terms of calculus notation? What is slope? Derivative. If you write on your paper then the derivative equals 0, if you show you know that that's what you're looking for, if it says horizontal tangent line, that's going to give you your first point. Okay, so again, this will be a free response question. Then you would find the derivative. I'm going to make you guys, I want to show you this. Because it is so similar to something you're going to have to do. Okay, 24 gives us this. What rule do we have to apply? Quotient. So Annie, can you apply quotient rule? I'm going to write it really quick. So bottom times the derivative of the top minus top derivative of the bottom over the bottom squared. What would f prime be?
It'd be so x plus 1
Good.
times 2x
Good.
minus x squared times
Perfect. And then it's all over.
x plus 1 squared.
Perfect. Everyone all right to hear? Okay, our goal is we're trying to figure out where is the derivative equal to 0. I would simplify on top, it's not bad. I would distribute the 2x. So I'd get 2x squared plus 2x. And then there's a minus x squared. I could combine the like terms, so I'd have x squared plus 2x divided by, what was the denominator? X plus 1 squared. Remember with quotient rule, never multiply out the denominator. It's going to be way easier to work with if you just leave it as quantity squared. Our goal is, when does this equal 0? What's our shortcut? When does a fraction equal 0? With which piece? Yeah. Sorry, say that again. When the top equals 0. Very good. A fraction equals 0 when the top equals 0. So even though at first we think we don't like working with fractions, they make this step a lot easier. If you have an equation equal to 0 and you're solving it without a calculator, you will always factor. So we can factor out the x, and we'd have x plus 2. Then we would set each fraction equal, or sorry, each factor equal to 0, and we get those two values. At the end of a question, always reread the problem to make sure that we've answered it. So the question said find the x coordinates of the points, so we get to stop. If it wanted the whole point, you'd have to plug that x coordinate back in to find the point. Okay. All right. So today your assignment, we don't have any new notes. Today your assignment is just your 2-7. But I do want to talk about one thing first, but just while we're here. So your assignment 2-7, you're going to do problems 1 through 25. So this is scored out of 50. Tomorrow is our question day. So this one is due before your test. So I'll put, I think I have the due date being tomorrow at midnight, but I guess I'll put the due date for Friday at 10:30. So it's due before you take your test. You have to have this submitted. Let me say Friday at 10:30. Okay, yeah. Okay, remember your test on Friday is going to start at 11. I believe I figured out a way that if you have an issue, so I think that there is a student who I ran into who was like, oh, they have a different class that's requiring a test at that time on Friday. So that student had asked if they could have it be at 12, so theirs was going to be 12 to 1. If for some reason you need a different window, you have to let me know. I can set it up for you, but only if you let me know. Okay, so you have to let me know ahead of time. I'm going to send out an email later today that will remind you. I'll say the test is going to be Friday at 11. If you need a different time, I'm going to ask you to reply to the email and tell me your different time. If you don't reply to the email, then I'm just going to assume you're good with Friday at 11. Okay, so what I want you to do right now, I want to practice this to make sure we don't run into any issues. Go into modules. So go ahead and take out your phone, open up your phone. We're going to practice this. So in modules, so this time we're not your phone out. So everybody's practicing this because I need you to submit it. It's a good practice question too. The question that I put in here is very similar to your test question too. So it gives us a chance to practice a question similar and make sure that we don't have any issues with submitting. Okay, so I think I have it under today, Wednesday. There's that link for practice test question AB unit 2. Okay, so if you click on this, oh, don't do this. Good. Is the image, does it show for you guys? So it's just me. Try that again. Oh, because I'm not in student view. That's why probably. Student view. Okay. Okay, so I want you to pull this up and then take out a separate piece of paper. Okay, so you should see this question. This question is very similar to one of the ones that you're going to have. When you submit, this is from like all of the times that I've had students submit work. First, keep in mind your test, your work has to be super clear. Okay, you get your points awarded for your work, not just for your answer. So if you're like writing sloppy, I can't read your work, I'm not going to give you credit. So you maybe need to like take more time on a test question than you would on just a homework question, right? Also, I've noticed when students take pictures on a test, don't write on paper back to back. Okay, so sometimes when you take a picture of an image, if you've written on the back, that writing comes through and sometimes it makes it harder for me to see. That's fine to do on homework, but on a test, only write on one side of the page. Does that make sense? Okay, so I want us to go through this. So we're going to go ahead and do this question. So I want you to do this on a separate piece of paper. Also, because you're going to have one very similar to this on your test. Okay, so we've got this function. I think I can open mine up in Notability. So you guys are just doing this on a piece of paper. And this is how you'll do it on your test. You'll just do your free response on a separate piece of paper. If it's helpful to you, like on your paper, you could write down the thing. I probably, if it was me on my paper, I would just write down the function. Okay, so there's the work my paper would look like on one. I'm just going to write out what the function is. So remember, on a free response question, I'm only going to ask you a free response question if I really care about your work. If all I cared about was your answer, then I would put it on multiple choice. Free response, I want to see what steps and work you're showing. So part A on this question says prove continuity using the 3-step process. This takes us back all the way to the beginning of the unit, but when you look at your assignment tonight, that 2-7 assignment, you have like 4 questions that ask you the same thing. Okay, because it keeps coming up because in order to talk about part B, differentiability, we have to talk about continuity. Who remembers what those 3 steps are? What 3 things have to happen for a function to be continuous? What would you do if, forget that we have to like show our steps. Yeah, Lance, what do you remember?
The point on the function has to exist. The limit has to exist, and they have to be each other.
Exactly. The point must exist. The limit, as we approach that number, must exist. And those 2 things, the limit as x approaches 1, must equal the value of the function at 1. Okay, so we're going to show our steps here, and so this would be a good thing to kind of refer back to, and you're going to get a chance to practice again in your assignment. Okay, so with this function, our goal is to go through those 3 steps. I'll do the easy one first. Does the function at 1 exist? Do we get a value out at 1? Yeah, What are we looking for? What about this tells us that that's yes? Yeah, Grant. Exactly, that equal to bar. As long as one of the two has an equal to bar, you take a 1 and you plug it in here. You don't have to show this step, but you could show that it's because we're plugging 1 in there. What do we get out? 6. So you have to, on your paper, write f at 1 equals 6. I'm going to put a 1 next to it. You don't have to label your steps, but that's basically one of our steps. Yeah, Allie. Exactly. The point is referring to which one has the equal to bar. If the question was this, if it didn't have that, if it didn't have an equal to bar, I would have said f at 1 does not exist. So it's not continuous at x equals 1. So if it didn't have an equal to bar, I'd be done. I'd say it doesn't work, can't do it. If it does, then we get to go on to another step. Now it has to do with limits. What we've been doing, our shortcut of like, is it continuous or not? We've been just taking 1 and plugging it in, right? But on a free response, we got to work on our math notation. So when we do this, we're going to actually take the limit from the left and the right. The rubric on these questions on the AP test always is specific, and it says like no credit if they don't consider one-sided limits. So you have to consider one-sided limits. What that means is you're going to take the limit as x approaches the number we're concerned with is 1. You have to approach from the left and the right. So I'll approach from the negative side first. So we do the 1 with the little negative. Make sure you name the function. So you have to say the limit as we approach 1 from the negative side of f of x. And we have to state what this is. How do you evaluate that limit as we approach 1 from the negative side? Are we on the first function or the second function? How do we decide? The first, right?
First.
Because here's 1, x is less than 1, so we'd be on the first function. So I would show 2 times 1 plus 4. No, it's not necessary that you show this, but it's helpful because then I know that you did plug it into this value. In case you do something silly with arithmetic, right? Sometimes we mess up our arithmetic, but if I see this step, I know that you're on the right track. Okay, so that gives us 6. Then you have to consider the other limit. Your notation matters. Remember, if it didn't matter, I would have put it on multiple choice. So you have to write it on your paper in that way. Your work has to be clear enough that I can see your notation. So the limit as x goes to 1 from the positive side of the function. I would then write, okay, I'm plugging 1 into this equation. So I'm going to write that's 1 squared plus 5, and I get 6. If these two things equal each other, you do have to write the limit as it goes to 1 without the plus or minus. So I kind of make an obvious statement. The limit as x goes to 1 equals 6. So really that's step 2. Step 2 required all 3 of those things. Right? It said the 3-step process. I've shown 2 of the 3 steps. The third step is just that those 2 things equal each other. Well, yeah, this one equals 6 and this one equals 6. We have to state the obvious. You have to just put them equal to each other. So we're saying, okay, yeah, the limit as x goes to 1 of the function did equal the function at 1. Then don't forget to answer the question. So we answer the question by saying, so f of x is continuous at x equals 1. And that is the work that I would want to see for part A. So you could see that this obviously could not be a multiple choice question. So a free response, I really do want to see your work. Any questions with that part? Okay, there was a part B. Part B says, is f of x differentiable at x equals 1? What's the first thing? The function has to be what in order to be differentiable? Continuous. It was continuous, so A was good, so I'd keep going. If it wasn't continuous, I could stop and say it's not differentiable because the function's not continuous. You wouldn't even have to check anything else. Then to see if it's differentiable, we want to make sure that there's not a sharp turn. So we want to compare the derivative from the left and the derivative from the right. So I would maybe start by finding f prime. Sorry, I screwed it up, but hopefully you guys have it. Let's write, what is f prime? Take the derivative of each piece. What's the derivative of the first piece? 2, right? Because the derivative of 2x plus 4 is 2. What is the derivative of the second piece? Whoops, I wrote that wrong. First piece was just 2. The second piece is 2x. Are you guys okay there? Notice one thing. Right now, I do not have an equal to bar. I don't know if the derivative exists at 1. I need to check to see if it exists at 1. Yeah, Hallie. No, so there was up here, right? There was on the original function. I don't know if f prime at 1 exists because if this function, let's say here's 1, if the function came in like that, the derivative would not exist. So I need to check for a sharp turn. And then if there's not a sharp turn, I could put the equal to bar. So this is how we check. It's very similar to how we check the left and the right derivative or limits on the function. So I'm going to take the limit as x approaches 1 from the negative side, but I write f prime. I'm just taking the left and right of f prime. And then I'm going to take the limit as x approaches 1 from the positive side of f prime. Okay, if I'm approaching 1 on f prime from the negative side, what would I get out? 2, because I plug 1 in here, there's nowhere to plug it in, so I just get 2. If I approach 1 from the positive side, I'd be on this, and I plug 1 into here. If I plug 1 into here, what would I get? 2. Hey, those equal each other. That's great. So that tells me that the limit.
Interruption. Johnson was ready for seniors with the last name of J through R.
So if they equal each other, that means that there is no sharp turn, which is great. That means as we approach one side, the slope was 2 and the other side was 2, so it would be smooth. So then I can conclude f of x is differentiable at x equals 1. Very similar to continuous, but we only have to check the left and the right-handed limits. Because it is differentiable, that allows me to come back up here and put an equal to bar. Turns out it doesn't matter which function you put the equal to bar on. If you chose to keep it on the bottom one, great. If for some reason you wanted to put it on the top one, great. It doesn't matter, but one of them would get it. Okay, what if instead of this, what if this one, for some reason, it was a different function, but if that came out to be 3, what would you say? Yeah, that there would be a sharp turn. So if they don't equal each other, then there's a sharp turn. And then I would say f of x is not differentiable. Yeah, Howie. If the question, let's read with how the question was worded. Not on this one because it just said, is it differentiable? If the question said find f prime, if it said find f prime, then you would if I wanted this. Okay, so what I want you guys to do now is submit this in that practice test. It's worth 0 points. I'm not giving you credit, but this will give me a chance that if you do something wrong, I can tell you now and not on your test. So you're just taking a picture of this practice work and you're hitting submit. Know that I have the submit limit. You only get 1 submission. So you might want to like preview your photo before you hit submit. Make sure that your photo is something that I'm going to be able to read. Okay, so you're just going to take a picture and you're going to hit submit. I'm going to look at those. I'm not going to like grade them because we did them together, but I'm going to look at them, and if I see that there's an issue with how you have it submitted, I'll make you redo it. Okay, so again, check. I'm going to email you in your Canvas email. How many of you, is it pretty easy? Do you guys get like a good notification when you get an email in Canvas? For me, it's kind of nice. It shows me a little red dot. Yes. Okay, so look for an email from me today. I'm going to say, I'm going to remind you that your test is Friday at 11. If you need a different time, you need to reply to that email and be specific about when you need yours to be. Okay, so that's all I had for you guys. So what you guys have for the rest of class is just working on this review. I want to show you, so your assignment is 1 through 25. To do more practice of what we just did, you can see questions like 22, 23, and 24. Do you see how those 3 questions, those are piecewise questions with the exact same questions that I just asked. Part A is it continuous? Part B is it differentiable? Practice those ones showing your work like I just had you show it on the other one. So practice it like you're doing it for your free response. Make sure you're using that correct notation. Okay? All right. So you guys have about 15 minutes. I will let you guys work. Do keep in mind one like 18. 18 says use a calculator for these problems. Your test this Friday will be a non-calculator, so I wouldn't ask you a question like 18. Still practice it. Next Friday's quiz will be a calculator required, so I'll ask you that question on next week's quiz. Okay.